test.
Thank you, Jordi, our president of WATS. Yes, I'm very happy to be here, and I thank the organizer, and it's a very nice combination that I celebrated just 2 weeks ago, my 15 years of involvement in the Rome laboratory, after the inspection and supervision of Professor Segura in 1998, November 1998, who gave the approval of the anti-doping authority at that time, the IOC Medical Commission, for the new deal of the Rome laboratory. And right after, I had to specifically learn this job, because whatever your experience, you cannot be ready to run an anti-doping laboratory if you have not been working in an anti-doping laboratory. So I interacted mostly with the laboratories of Cologne and Lausanne. So I think this session is a very good celebration for me, and I'm very honored to be here. When you give me a template, I always feel not comfortable, so maybe I put the title a little too low, but you know, the Italian genius in a way. Okay, I appreciated very much the introductory remarks of Mr. Blatter. I found his introductory speech enlightening, and I added during the coffee break one slide that I think can further underline his meeting with His Holiness the Pope, because in my opinion, this is the beginning of doping, when they forbid you to take something because otherwise you become like God, and what do? You take that something. The difference is that the anti-doping tests at that time were really with 100% safety and solidity, so we are still paying the consequences of that. But, okay, this is not the case today, because I think the most common question I've been asked in these 15 years is this one: why don't you catch them? Of course, this question is reversed when you catch somebody important, and they start to say that you are too strict, and when you don't catch them, you are too relaxed. But I think this is the most common question I've been asked in these years. If the person who asked the question is very polite, they know the statistics, and they say, is it possible that it's only 2%? And I'm trying to give some personal answers, of course, from a laboratory point of view, but that can be used to think about how to improve the efficacy of our test. The first answer is that sport is 98% clean, and I do not believe this is a good solution, maybe just because of statistical reasons. So not everybody who drives through a red light takes a ticket, at least not in Italy. So it means that there is an underestimation from the clear positive case of the laboratory and the actual number of doping offenses that remain not detected. Another criticism, another weakness can be that our methods may not be too effective, or that the criteria to report an adverse analytical find are too strict, and I will start with these two things. This is our ideal situation. If it is, let's say this is urine, you take a doping substance, then after a while, I'm sorry if there is any pharmacologist, this curve is not so symmetrical. I idealize it. It starts to be excreted, it reaches a maximum in urine, and then it goes out. And this is the limit of sensitivity of our technique. It means that if the athlete takes the forbidden substance here, we can detect from here to here for this period of time. And to detect, we have to have enough sensitivity of the method. We have to see the substance, and we have to have selectivity. And it's not physiological. Like, okay, I see testosterone, but it is not endogenous testosterone. I see erythropoietin, but it's not endogenous erythropoietin. I see amphetamine, but it's not endogenous amphetamine. Of course, amphetamines are not endogenous. So we already understand what is easy and what is difficult. Our life has been more and more difficult over the last 40 years, because at the beginning we had, let's say, easy things, things that were not produced by the body, that were active in high concentration, that were excreted in significant amount unmodified, that were effective if taken just before competition, that were excreted in urine, that could be detected by chromatographic spectrometric techniques that are the gold standard for the anti-doping laboratories, and for which all reference materials, all the reference chemical digital prints were available. Today, we are moving to something that is more difficult because substances, the most difficult to detect, are pseudoendogenous, that are virtually identical to those that are naturally present in the body, can be taken out of competition. So if you don't have a program of out-of-competition testing, at the time of competition, they are already eliminated, even because they are active at low concentration, have a short half-life, do not go too much in urine, cannot be detected too easily by chromatography mass spectrometry. Sometimes you don't have any reference materials, and some other time, and most often, they are administered together with other drugs. So let's try to define what is easy and what is difficult. I think the difficulty increases when the similarity with somebody that is in the body increases. And the difficulty increases when the concentration decreases. So if something is here, it's easy. And if you move toward the origin, it's difficult. I try to map all the things that are in the list today. And I see that if this is a combination of sensitivity and selectivity in 1970, we had a relatively very huge amount of false negative results. And the technological evolution does nothing but shifting this curve toward the origin. So by the increase in technology, by the increase in knowledge, by the increase in scientific expertise of the anti-doping system, not only the anti-doping laboratories, we are able to progressively reduce the number of false negatives. And if you take the classes, I think this may be a tentative positioning of the target of our activity in the diagram of the difficulty. And I think if we put in green what is relatively easy to find, in orange what we need to improve but is still detectable, and in red what we need more activity, I think we can also try to put a combination between direct methods, the traditional ones. The target is a compound, what in toxicology is called the detection of markers of exposures. I've been exposed to that substance. And markers of effect, that is the basis of biological passport. I think more or less what is on the right can be still found by direct methods, and what is on the left is mostly by biological passport. Of course, there is more overlapping, but I think it is ridiculous to look for a diuretic with a passport, and it is so far impossible to look for autologous transfusion only with a direct method. So I think this is already a combination to stress what has already been said by Martial and Jordi, that the two strategies have to move together. There is not a replacement one of the other, but they just cover different areas of anti-doping science. So I think our methods are good with this limitation. I think that criteria are not too strict because we have always to remember what is our first goal. That is not to sanction the bad athletes, but before that, there is the protection of clean athletes. So we may pay the price to lose some positive, but to be sure that we will never, ever, ever sanction somebody that is not guilty. Let's see what the research can do, again, from the laboratory point of view. What is that we do not see in our methods today? What is the invisible? Or this doping substance, this doping method is invisible. What do we mean by invisible? By invisible, we mean unknown. The most famous case maybe is the tetrahydrogestrinone and the so-called designer steroids, somebody we do not know it exists. And we have seen by Dr. Geyer that there can be two strategies also for the unknown. One direct with a following by mass spectrometry common fragmentation pattern, and indirect to look, for example, for the suppression of the steroid profile. So it's unknown, but it can become visible in a while. Then we have the identical. I think so far, human endogenous insulin is not distinguishable by a direct method from the identical recombinant one. So we have to move by the passport. And then we have what I call the masked, so something that would be detectable, but that by some extent is made invisible by masking strategies. I am married happily, again, a second thing strange for an Italian, since 21 years with a woman that is from Venice, so masks for me are something of the Venetian carnival, something like this, very elegant. Oh, yeah, fantastic. But in sport doping, what is masking? Masking is something that traditionally was meant to reduce the concentration, to stop the excretion, or to degrade the samples, even if the latter, for example, protease for EPO is more correctly defined as tampering, not masking. Anyway, something that can make the activity of the anti-doping laboratories more difficult. And masking can interest all the anti-doping process. I do not have only a masking agent that dilutes the urine. I can have a masking agent that is pre-administered to make the compliance with the drug better, that can be post-administered to make the detection more difficult, or that can be added to the sample with the results of either changing drug metabolism and pharmacokinetics or interfering with the analytical procedure. This is, for me, is the whole process that can be interested by masking agent. And time is short, I want to consider just two, like exemplary cases of non-conventional masking strategies. The first one involves drug delivery systems. Liposomes are made of phospholipids that are organized in a way that they can be something like a very, very, very small football ball, like that one. And the drug can be on the surface, can be on the thickness, or can be inside. And what happens? It happens that the distribution and the pharmacokinetics parameters of the drug are no longer relevant, and they become secondary to that of the drug delivery system. Why we have started to study drug delivery system? Because I think they can interfere with all processes. I can use them to make homemade sustained release or controlled release formulation, or I can use them as scavengers to capture doping substances if I know that I will have to undertake a doping test. I can add it to the sample to increase the matrix effect, and I can use them to interfere with our analytical methods. So we started this because in many investigations in Italy, when you read that the police or the carabinieri or the financial police confiscated some drugs for doping, you take the list and you see that there is growth hormone, okay, doping. EPO, okay, doping. Testosterone, okay, doping. Caffeine, okay, no longer doping, but I can understand. Liposome forte. Why do they use liposome forte for? Is something like a good luck, bring liposome forte with you, it will bring good luck? No, I think they take it. Why do they take it? The reason why it's registered is for neurophysiological unbalancement like in jet lag. Now, if you have a stage of the Giro d'Italia from Pesaro to Rimini, you do not change the time zone. I don't think this can be used for jet lag. So we thought that this could be used for masking. And we indeed performed some experiments that showed that the excretion and the detection of anabolic steroids is made more complicated by liposomes. And then after, we have seen that on the parallel market, there is somebody, I will make it bigger, that is already marketing on the black market steroids vehiculated with liposomes. So I think we are very happy that now we have the class S0 of the WADA list, non-registered substance. So we are allowed to screen for them and to see how often we can find in urine. If we will find 10 samples out of 12,000, it will not be a problem. If we find 1,000 samples, it will be a problem. And the follow-up of this study that is in a way more interesting is when you use liposomes not only to bind or vehiculate steroids, but when you use them for proteins. And speaking about the organization of the anti-doping laboratories, you know that we have a screening, initial testing procedure and a confirmation procedure. And the initial testing procedure should be as easy, as quick, as economical as possible. And the ideal initial testing procedures in the lab is the one for synthetic hemoglobins. You simply take a blood sample, you centrifuge, and you have the supernatant yellow and the red blood cell fraction red, unless you have hemolysis. So if the supernatant in yellow, the sample is negative and does not deserve any further investigation. The synthetic hemoglobins, the H box, were included in the list at the IOC time and were maintained in the list by the WADA. So they are banned since, I think, 13 years. Number of positive, 0. Okay, difficult to find, but in my opinion, not more difficult than tetrahydrogestrinol. Number of positive in 13 years, 0. Are they effective? Yes. Number of positive, 0. Fantastic. This is the screening. This is a sample with free hemoglobin, and this is a sample with no free hemoglobin. Very easy. The picture is not so good, but it adds a sort of mystery to this. Then on the sample on the right, it can be hemolysis or it can be synthetic hemoglobin. You have many confirmation procedure. We have a pre-confirmation that is based on capillary electrophoresis, and you can distinguish the endogenous hemoglobin from all the rest. So if it is hemolysis, you have only this peak. If it is not hemolysis, you have one of these peaks. We always had hemolysis on samples that were red. What about samples that may be masked? So somebody calls the liposomes that contain hemoglobin inside hemosomes, and their size becomes slightly smaller of that of a red blood cell. So we are, in a sense, speaking of artificial red blood cells and not artificial hemoglobin. How easy is to prepare that? We made in the lab in maybe 3 hours, so it's not difficult to put hemoglobin inside or around a liposome. What happens if you spike a sample with... Is my time over? I go with this? No? Oh my God, what did I do? I broke it. Sorry. Stop the time, please. Otherwise, the Italian will finish late. Oh, please. Okay, is it? I can use the mouse if this. Let me see. Yes, it works. This is true. It's used for some resuscitation therapy, or has some military application on the war field, because you cannot bring all the blood bags of different groups. So to recover injured soldiers, you can use synthetic blood, synthetic hemoglobin. It's still not in therapy, but hemoglobin vehiculated by liposome exists. And I cheated you before. This is really a sample in which I added synthetic hemoglobin. This is a sample in which I added the hemosome. So this strategy will allow to skip the screening for synthetic hemoglobins. I have no idea if somebody is using this, but the result is that we did not have any positive in 14 years. So let's consider this also as a potential contribution to the total number of false negative. I'm speaking of H-box because they are visually nice to be presented at the conference, but it can work for EPO, it can work for GH, it can work for insulin. if we do not go for the visual examination, and if we use the ADVIA that gives the difference between total hemoglobin and cellular hemoglobin, you still see that when it is free hemoglobin, I see the difference. When I add the hemosomes, they are not detected, not even by an automatic hemoanalyzer. So it is a real masking agent for our screening. Of course, we cannot publish this before we publish the method to detect this. And these are now hopefully in print. I can anticipate that there are two strategies. One is on blood by flow cytofluorimetry, and another is on urine by monitoring the phospholipid population. You use a double tagging. You have 4 quadrants. This is nothing. This is only hemoglobin. So let's say this is hemolysis. This is only liposomes, if somebody is taking liposomes for illicit therapy. And this is hemoglobin in liposomes. So it is detectable. This is a spike at 1 to 10. That is roughly what you have for a transfusion, is 1 or 2 blood bags for 5 liters. So more or less the sensitivity is there. Each one of these is an event. So theoretically, with just a few of these dots, you can say that hemosomes are there. And this is instead the population of phospholipids in urine. And if you go by classes, you see that phosphatidyl ethanolamines are not endogenously present in a significant amount, while they are constituent of the 2 drugs that we have considered. So the presence of this class of phospholipids can be an index, a preliminary index of the presence of degradation product of liposomes in urine. Second strategy, quickly, drug-drug interaction. All the Bibles that we study, all the articles that the pharmaceutical companies are publishing to register their drugs are based on the administration of similar or logically and rationally association of different drugs. There is no study that gives you what happens if you take glucocorticoids with insulin, branched chain amino acids, caffeine, and a diuretic. There is no literature, and we cannot reproduce this. So we can just postulate what happens when different classes of drugs are taken together. And let's go back to the original picture. This is the ideal situation. If there is an interaction, a drug-drug interaction, it can be that this shape or this position is changed. So if this is a metabolite, and if I have an inhibition of the metabolism, I have a lower peak. If this is the parent compound, and I have an activation, an induction of metabolism, this is the decrease. If this is a metabolite, and I have a blocking of a metabolic pathway that is reinstated later on, I have a shift in the kinetic of excretion. In all cases, I risk a false negative. So this is just an example. We have studied different classes. We have taken one non-prohibited substance that now is in the target, especially with the new technical document of endogenous steroids that has been recently approved by the WADA, and that I consider a very good document. Co-administered with one of the most famous synthetic anabolic steroids that we have heard a lot this morning by Dr. Geyer. And this is what happens to the metabolic profile. This is a person taking 5 milligrams of methandienone with ketoconazole. And you see that even the long-lasting metabolite has an excretion window that is reduced. Is this invisible? No. But it means that if in this case, you can make a test 10 days after the last administration. With ketoconazole, you have to go there 7 days after. So the invisibility window is extended. And this is not only for the long-lasting metabolites, but also from some other key metabolites that the laboratory screen in their analysis. How to counterbalance this? Always including as many markers as possible in the screening. You may also find some additional metabolites that are produced when the production of one metabolite is blocked. And then, of course, monitoring also the non-banned substance. That is easier with the new version of the code, I understand, because this is not research, and we do not need the athlete consent. This is optimization of the method. So I think we can screen for an antifungal agent even if it is not specifically banned, because it can improve the efficacy of our techniques. Last point, testing. I may say that if a sample contains a marker of a banned substance and reaches the lab, the sample is reported as an adverse analytical finding. Of course, with the limitation of the invisible, of the red things. But this is a sample, this is not an individual. This is not a doped athlete. This is a sample taken from an athlete. If the substance is inside and is above this LOD, we see it. If it is not inside, even if the athlete has used it, we report a negative. So in the ideal situation, no problem. If the sampling is done not perfectly okay, if it's done here, we can in a way improve. We can decrease the limit of detection and decrease the limit of detection and decrease the limit of detection, down to the point that we can see the substance also on a longer detection window. But if the sampling is made here or here, it's useless. There is nothing we can do. There is no perfect laboratory method that can counterbalance the lack of efficacy of a poor, of an unlucky sampling session. We cannot do miracles. If the substance is there, we may see it. If the substance is not there, there is nothing we can do. My conclusions. I think we do not report false positive, and if we do, we pay the consequences. We need more knowledge, especially on the non-registered drugs and especially on drug delivery systems. I have spoken of liposomes, but there is the whole class of cyclodextrins on which Cologne worked 5 or 10 years ago. That is also another possibility of masking. The metabolic profile that you study in school, at the university, or literature may not be sufficient to understand what happens in a doping sample because of the co-administration of other substances. And don't forget that some gray zones can be traced also to out of the lab activities. Quickly, I have to thank my federation because supports also the research activity of the laboratory. I have to gladly thank the WADA because they were so crazy to believe in this project and to fund 3 of them in the last years. And I have also to thank all the colleagues of the WATS network, of which Professor Segura is president, because of the continuous scientific interaction we have. And on a smaller scale, my good friends and colleagues, Xavier, Monica, and Francesco Donati, with whom I continuously discuss this thing, the enthusiasm of the students and all of my staff, and of course you for having listened to me for these 20 minutes. Thank you.